So, AI coding assistants are everywhere, right? They're letting us build things faster than we ever thought possible. But here's the thing. All that speed can come with a pretty big hidden cost. Just pure chaos. So today, we're going to dig into a tool called Draft. The whole idea behind it is to bring some real enterprise-level discipline to this brand new world of AI-powered development. All right, let's get into it.
I mean, this is the question, isn't it? It's the one every engineering manager, every team lead is asking themselves right now. Yeah, we're getting code spit out in seconds, stuff that used to take hours, maybe even days. But is it the right code? Does it actually fit into our existing architecture? Does it solve the real business problem or just the one the AI kind of guessed we had? And that right there is the heart of the problem. This amazing speed boost we're getting from AI, well, it often comes at a steep price: our engineering discipline. We end up skipping all the important stuff, the planning, the specs, the careful design choices, and where does that lead? Straight to a mountain of technical debt and some seriously chaotic code bases.
So this brings us to what you could almost call the AI coding paradox. It's this weird situation where the very tool that's supposed to make us faster can actually, in the long run, slow us way down. How? By helping us create a huge pile of poorly designed, assumption-driven code that, guess what, we have to go back and fix later.
Okay, let's break down what this chaos actually looks like. Think about it. An unmanaged AI, it doesn't ask you clarifying questions. It just guesses at what you want. It might pick some random library your team never uses, or choose an architectural pattern that totally clashes with your existing code. And this is a big one. It often skips verification. It'll just say, yep, feature's done, with absolutely zero proof that it actually works the way it's supposed to.
So you have to ask, where is all this chaos coming from? Well, the argument here is that the root cause is the very interface we're all using, chat. Just a simple chat window. We're trying to build really complex, mission-critical software using a tool that's, let's be honest, just not built for structured engineering. It's like trying to build a house with a Swiss Army knife.
And this is exactly why chat just falls apart for any serious team-based development. I mean, the context window fills up and the AI literally forgets what you two decided on 30 minutes ago. There's no long-term memory, so every single session is like starting from scratch. And maybe the biggest problem for enterprise teams, your whole design process is completely invisible. It's unsearchable, it's unauditable, it's just trapped in your private chat history, totally useless to anyone else on the team.
So this comparison really lays it all out. On one hand, you've got the chat-driven way, context that just disappears, no version history, and it's totally invisible to your teammates. But with the draft approach, instead of a chat window, you have actual files in your repo acting as a persistent memory. Instead of no history, you get git-tracked specs with diffs. And instead of invisible conversations, you get planning documents that your whole team can review in a pull request, just like you would with code. It's a night and day difference.
Okay, so we've talked a lot about the problem. What's the solution? Well, Draft's core philosophy is something called context-driven development. It's all about taming the AI by giving it super clear guardrails before it ever writes a single line of code.
Now this is the big idea right here. Your project's context, the product vision, the tech stack, the architecture, it's no longer just a chunk of text you frantically paste into a chat window hoping the AI remembers it. Instead, it becomes a real, managed artifact in your repository, just like your code. It's all documented in version-controlled files that the AI is forced to follow.
I really like this because it shows how this works in practice. It's like a funnel, you see? You start super broad with the overall product vision, like build a task manager. Then you get more specific with the tech stack, use React, TypeScript, Tailwind. Then you define the architecture. By the time you get down to a specific feature spec and a step-by-step plan, the AI has almost no room left to make wild, random choices. You've given it a very clear, narrow path to success.
All right, that's the philosophy behind it. But what does this actually look like for a developer day-to-day? Let's walk through the draft workflow, from a basic idea all the way to verified code.
So the whole process is really structured. Step 1, you define the context, the whole project landscape. Then, for any new feature, you create a spec and a plan. And only after that's done and approved do you move on to implementation, which itself is done in a test-driven cycle. And finally, you verify everything, not just that the code works, but that it actually meets all your quality and compliance checks.
And the way you interact with all this is through a few simple commands. You've got /draft init to set everything up, and it can even discover the architecture of a project you're already working on. Then there's /draft new track, which kicks off writing the spec and plan. When you're ready to code, you just use /draft implement to have the AI execute the plan, one task at a time. And then you have commands like /draft validate and /draft review to handle all the quality checks right inside your workflow.
Now, this is all pretty cool for a solo developer, sure, but the real magic, the real payoff, happens when you bring this to a team. It's all about getting everyone on the same page before anyone writes a single line of code. And this right here is the absolute heart of it. Honestly, if you're an engineering leader, this might be the most important point of all. Think about it. Catching a design mistake in a simple text document is incredibly cheap and easy to fix. Catching that same mistake after thousands of lines of code have been written, that's a nightmare. It's expensive, it's slow, and it's frustrating for everyone.
This really shows you the massive shift in thinking. The old way, the chat-driven way, the AI just writes a bunch of code and then everyone argues about it in a giant PR when it's way too late to make big changes. The draft approach, the AI writes a spec first. Your team debates a simple text file. Disagree with something? You just edit a sentence. You don't have to refactor an entire module. It's a game changer for team collaboration.
So what does this actually mean for your team day to day? Well, for starters, your reviews get way faster because you're just approving the high-level approach, not nitpicking implementation details. You'll do far fewer rewrites. The specs themselves become amazing documentation that explains the why behind the code, not just the what. And onboarding new people? So much easier. You just tell them, hey, go read the specs for the last few features, and they're up to speed.
Okay, so after hearing all that, the big question is draft actually for you? Is this level of structure a good fit for your team and your projects?
This is a really good fit anytime you're making real architectural or API design decisions. It's perfect for any work that's going to be reviewed by other people on your team or for any complex feature that touches multiple files. Basically, if you've ever had one of those just go code it moments that turned into a month of painful rework, yeah, that's a pretty good sign the draft is for you.
But we have to be super clear here. This is not for everything. This is a tool for disciplined engineering. It's not for what you might call vibe coding. If you're fixing a one-line bug, correcting a typo, or just hacking on a prototype you're going to throw away, this whole process is definitely overkill. It's all about applying structure where it actually adds value.
This quote right here just perfectly sums up the entire mindset shift. With a tool like Draft, the AI stops being this magical, autonomous coder that you just cross your fingers and hope does the right thing. Instead, it becomes an incredibly fast and efficient executor of a plan that you, a human, and your team have already carefully reviewed and approved.
And really, that's the final question we're left with. As you start bringing these incredibly powerful tools into your own workflow, you have to decide what role you want them to play. Are you looking for an autonomous coder that makes critical design decisions inside a black box? Or do you want a disciplined executor, something that can bring your team's carefully considered plans to life at lightning speed? The choice you make is really going to define the future of your code base.